Preparing for a SQL for AI interviews interview. You've reached Candy Mentor, and this video is for you. We'll walk through 25 key questions you're likely to face. For each one, you'll see what the interviewer is testing, the core concepts you should cover, and a sample answer. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you explain the difference between inner join, left join, right join, and full outer join? The interviewer wants to assess your foundational SQL knowledge, ability to reason about table relationships, and awareness of how join choice affects row counts and downstream analytics. While answering, focus on matching keys, preserved versus discarded rows, nulls introduced by outer joins, and why AI datasets often require careful join decisions before modeling. An inner join keeps only rows with matching keys in both tables. A left join keeps every row from the left table and adds matching right side data, with nulls where no match exists. Right join is the reverse. And full outer join keeps everything from both sides. In AI workflows, I use joins carefully because dropping unmatched users or products can bias the training data and change model behavior. Question 2. Given an events table, how would you find the top 3 most active users per day? This question evaluates your ability to use window functions, partition data by time period, rank records correctly, and solve practical analytics problems common in AI product datasets. Make sure to cover grouping events by user and day, applying rank or row number over each day, filtering ranked results, and handling ties depending on business requirements. I would first aggregate events by user and date to get daily activity counts. Then I would apply a window function such as row number or rank, partitioned by event date and ordered by event count descending. Finally, I would filter where the rank is less than or equal to 3. If ties matter, I would use rank or denser rank. If the business wants exactly 3 users, I would use row number. Question 3. What is the difference between where and having, and when would you use each? The interviewer is testing your understanding of SQL execution logic, filtering before versus after aggregation, and your ability to write correct analytical queries under interview pressure. In your answer, talk about row-level filtering, aggregate-level filtering, group-by interaction, performance implications, and simple examples such as filtering transactions before summarizing revenue. Where filters individual rows before aggregation, while having filters grouped results after aggregation. For example, if I want transactions from 2024 only, I put that condition in where before grouping. If I want customers with total spend above $1,000, I use having after group by. I prefer filtering early with where when possible because it reduces the data processed by the aggregation step. Question 4. How would you identify duplicate rows in a table and keep only the latest record? The interviewer wants to assess your practical data cleaning skills, especially deduplication logic, window functions, timestamp handling, and preparation of reliable AI training datasets. Be sure to mention business keys, duplicate definitions, row number partitioning, ordering by updated timestamp, deleting or selecting the latest row, and validating duplicate removal. I would first define the duplicate key, such as user-id plus evented, because duplicates depend on business context. Then I would use row number over that key, ordered by updated at descending, so the latest record gets row number 1. I can select only RN equals 1 for a clean dataset, or delete rows with RN greater than 1. I would also check counts before and after to avoid accidental data loss. Question 5. How do window functions differ from group by aggregations? This question evaluates your understanding of advanced SQL analytics, especially preserving row-level detail while calculating aggregates needed for features, rankings, comparisons, and model inputs. While answering, focus on row preservation, partitioning, ordering, use cases like running totals or ranks, and why group by collapses rows into summary-level output. Group by collapses rows into one row per group, while window functions calculate values across a group, but keep the original row granularity. If I calculate total orders by customer with group by, I get one row per customer. With sum over partition by customer ID, every order row can still show that customer's total. That is useful for feature engineering, where I often need both the event detail and historical context. Question 6. Write a SQL approach to calculate a 7-day rolling average of daily model requests. The interviewer is testing your ability to handle time series data, use ordered window frames, and create monitoring metrics relevant to AI model usage and production systems. Make sure to cover daily aggregation first, ordering by date, using rows or range window frames, handling missing dates, and interpreting rolling metrics for monitoring trends. I would first aggregate raw request logs to daily request counts. Then, I would use average daily requests over an ordered window by date, with a frame like rows between 6 preceding and current row. One important detail is missing dates. If there are no requests on a day, I may need a calendar table and zero-fill those dates. Otherwise, the rolling average may overstate usage by ignoring inactive days. Question 7. How would you design a SQL query to measure user retention after an AI feature launch? The interviewer wants to assess your ability to translate a product analytics question into SQL, define cohorts, calculate retention, and avoid misleading user engagement metrics. In your answer, talk about cohort definition, first exposure date, return activity windows, distinct users, denominator discipline, and comparing retained users to the original cohort. I would define the cohort as users first exposed to the AI feature on the launch date or during a launch window. Then, I would join that cohort to later activity events and count distinct users active on day 1, day 7, or day 30. Retention should use the original cohort size as the denominator, not only active users. I would also separate feature-specific retention from general app activity if the business question requires it. Question 8. What are common ways null values can affect SQL results? This question evaluates your awareness of SQL null semantics, data quality risk, and how missing values can distort aggregates, joins, filters, and machine learning features. Be sure to mention 3-valued logic, count differences, join behavior, coalesce, aggregate handling, and why null treatment should match business meaning, not just convenience. Null means unknown or missing, so it behaves differently from 0 or an empty string. Comparisons like column equals null do not work. I need is null. Count column ignores nulls, while count counts rows. In joins, null keys generally do not match. For AI datasets, I avoid blindly replacing nulls with 0 unless 0 is meaningful. I usually profile null rates and decide whether to impute, flag, or exclude. Question 9. How would you optimize a slow SQL query used to generate training data? The interviewer is testing your performance troubleshooting process, including query plans, indexing, data volume reduction, joins, aggregations, and production reliability for AI pipelines. While answering, focus on reading the execution plan, filtering early, indexing join keys, avoiding unnecessary columns, materializing expensive steps, and validating that optimization preserves results. I would start with the execution plan to find bottlenecks such as full scans, expensive joins, or large source. Then I would reduce data early with selective where clauses, select only needed columns, and ensure join and filter keys are indexed or partition aligned. For repeated feature builds, I might materialize intermediate aggregates. After tuning, I would compare row counts and key metrics against the original query to confirm correctness. Question 10. What is the difference between row number, rank, and denser rank? The interviewer wants to assess your command of ranking functions, tie handling, deterministic ordering, and practical use in leaderboards, deduplication, and top-N analytical queries. Make sure to cover unique numbering, skipped ranks, non-skipped dense ranks, tie behavior, order by requirements, and choosing the right function for business logic. Row number assigns a unique sequence even when values tie. Rank gives tied rows the same rank, but leaves gaps afterward. Denser rank also gives tied rows the same rank, but does not leave gaps. If two models tie for first, rank produces 1, 1, 3, while denser rank gives 1, 1, 2. For deduplication, I usually use row number. For fair rankings, I use rank or denser rank. Question 11. How would you prevent data leakage when building model features with SQL? This question evaluates your understanding of machine learning data leakage, temporal joins, feature cutoffs, and how SQL feature engineering can accidentally use future information. In your answer, talk about prediction timestamp, point-in-time correctness, filtering features to available history, avoiding target-derived fields, and testing leakage through validation performance. I would anchor every training row to a prediction timestamp and only use data available before that timestamp. For example, if predicting churn on June 1, I should not include activity from June 2nd or labels created later. I would use time-bounded joins and feature windows like last 30 days before prediction. Leakage often shows up as unrealistically strong validation results, so I also review features for target-derived information. Question 12. How would you create train, validation, and test splits using SQL? The interviewer is testing your ability to prepare machine learning datasets responsibly, including random versus time-based splits, reproducibility, stratification, and avoiding user-level contamination. Be sure to mention split strategy, stable random hashing, chronological splits for time-dependent data, keeping entities together, and preserving label distribution where appropriate. The split depends on the problem. For time-sensitive prediction, I prefer chronological splits, older data for training, later data for validation and testing. For more static data, I can use a stable hash of user ID to assign records reproducibly, such as hash modulo 100. I also make sure one user does not appear across multiple splits if that would leak behavior. For classification, I check that label rates are reasonably balanced. Question 13. How would you calculate precision and recall from a predictions table in SQL? The interviewer wants to assess your ability to connect SQL with model evaluation, derive confusion matrix components, and compute classification metrics directly from stored predictions. While answering, focus on true positives, false negatives, thresholded predictions, conditional aggregation, division safety, and interpreting precision versus recall trade-offs. I would first convert prediction scores into predicted labels using a threshold. Then I would calculate true positives, and false negatives with conditional sums. Precision is true positives divided by true positives plus false positives, which tells me how accurate positive predictions are. Recall is true positives divided by true positives plus false negatives, which tells me how many actual positives I captured. I would use NULL to avoid divide by zero errors. Question 14. What is a CTE, and when would you use it instead of a subquery? This question evaluates your ability to structure readable SQL, break complex transformations into logical steps, and understand when CTEs improve maintainability or affect performance. Make sure to cover with clauses, readability, reuse, debugging, recursive CTEs if relevant, optimizer behavior, and cases where temporary tables may be better. A CTE, or common table expression, is a named temporary result defined with a with clause for use in the main query. I use CTEs to break complex logic into readable stages, such as cohort creation, feature aggregation, and final scoring data. They are easier to debug than deeply nested subqueries. Performance depends on the database optimizer, so for very expensive repeated steps, I may use a temporary or materialized table. Question 15. How would you find users whose current activity is significantly higher than their historical average? The interviewer is testing your ability to combine current period metrics, historical baselines, windowed aggregations, and anomaly-style logic relevant to AI monitoring or behavioral analytics. In your answer, talk about defining current and historical windows, computing averages and standard deviations, comparing ratios or z-scores, and excluding sparse histories. I would define a current window, such as the last day, and a historical baseline, such as the prior 30 days excluding the current day. Then, I would aggregate activity per user for both periods and compare current activity to the historical average. A simple rule could be current activity greater than 3 times average, but a z-score is better if variance matters. I would also require enough historical observations to avoid noisy flags. Question 16. How do indexes help SQL performance, and what are their trade-offs? The interviewer wants to assess your database fundamentals, especially how indexes accelerate lookups and joins, why they are not free, and how to choose indexed columns. Be sure to mention B-tree-style lookups, join and filter keys, cardinality, write overhead, storage cost, maintenance, and avoiding indexes that are rarely used. Indexes help the database find rows without scanning the entire table, especially for selective filters, joins, and ordered lookups. I would consider indexing columns used frequently in where, join, or order by clauses, particularly high cardinality columns. The trade-off is that indexes consume storage and slow inserts, updates, and deletes, because the index must be maintained. So I do not index everything. I use query patterns and execution plans to decide. Question 17. How would you handle many-to-many joins that unexpectedly inflate row counts? This question evaluates your ability to diagnose join explosions, understand table grain, protect metric integrity, and build reliable datasets for analytics and machine learning. While answering, focus on identifying table grain, checking key uniqueness, pre-aggregating or deduplicating, validating row counts, and deciding the intended business relationship. I would first inspect the grain of each table and test whether the join keys are unique. If both sides have multiple rows per key, the join can multiply records and inflate metrics. Depending on the goal, I might deduplicate one side, pre-aggregate to the correct grain, or add more join keys such as date or event ID. I always compare row counts before and after the join, and validate totals against known benchmarks. Question 18. What is point-in-time correctness, and why does it matter in feature engineering? The interviewer is testing your understanding of temporal data integrity, feature stores, historical backtesting, and preventing AI models from training on information unavailable at prediction time. Make sure to cover event time, feature availability time, as-of joins, delayed data, backfills, and how point-in-time errors create inflated offline model performance. Point-in-time correctness means every feature value reflects only what was known at the prediction moment. It is not enough to use event dates. I also need to consider when data became available. For example, a payment event may occur today, but arrive in the warehouse tomorrow. In SQL, I use as-of joins and feature cutoffs to avoid future data. Without this discipline, offline performance can look excellent, while production performance fails. Question 19. How would you compute conversion rate through a multi-step AI product funnel? The interviewer wants to assess your ability to model event sequences, define funnel steps, apply time windows, and calculate conversion metrics without double counting users. In your answer, talk about distinct users, ordered events, step timestamps, eligibility windows, numerator and denominator definitions, and whether users must complete steps sequentially. I would define each funnel step clearly, such as viewed AI suggestion, clicked suggestion, accepted output, and returned next day. Then I would identify each user's first timestamp for each step and enforce the required order. Conversion rate from step 1 to step 2 is users completing step 2 divided by users completing step 1. I would use distinct users, not raw events, unless the business explicitly wants session-level conversion. Question 20. How would you query semi-structured JSON data stored in a SQL table? This question evaluates your ability to work with modern data warehouse formats, extract nested attributes, flatten arrays, and transform raw AI logs into analyzable tables. Be sure to mention JSON path extraction, casting types, flattening repeated fields, handling missing keys, performance considerations, and promoting frequently used fields to columns. I would use the database's JSON functions to extract fields by path, cast them into proper SQL types, and flatten arrays when each element needs its own row. For example, model logs may store prompt metadata, latency, and token counts inside a JSON payload. I would handle missing keys with safe extraction or coalesce. If a JSON field is queried often, I would consider materializing it as a typed column for performance and governance. Question 21. How would you detect drift in model input features using SQL? The interviewer is testing your ability to use SQL for model monitoring, compare production feature distributions, and identify data shifts that may degrade AI performance. While answering, focus on baseline versus current windows, distribution summaries, null rates, categorical frequency changes, numeric percentiles, and alert thresholds for investigation. I would compare recent production feature distributions against a baseline period, such as training data or the prior month. In SQL, I can calculate null rates, means, standard deviations, percentiles, and category frequencies by time window. For example, if average session length drops sharply or a category disappears, that may indicate drift or pipeline breakage. SQL is often the first monitoring layer before deeper statistical tests or retraining decisions. Question 22. What are transactions and isolation levels, and why might they matter for AI data pipelines? This question evaluates your understanding of database consistency, concurrent reads and writes, repeatability, and how unstable source data can affect feature generation and model training. Make sure to cover atomicity, consistency, dirty reads, repeatable reads, snapshot isolation, concurrent pipeline risk, and choosing consistency based on workload requirements. A transaction groups database operations so they succeed or fail together. Isolation levels define what one transaction can see while another is running. In AI pipelines, this matters because training data built during partial updates may be inconsistent. For example, features may reflect today's events while labels are still loading. Snapshot isolation or a committed data version helps create reproducible datasets. The goal is consistency without unnecessarily blocking operational workloads. Question 23. How would you sample data in SQL for model development without introducing bias? The interviewer wants to assess your practical judgment in reducing dataset size while preserving representativeness, label balance, user independence, and reproducibility for AI experimentation. In your answer, talk about random sampling, stratified sampling, stable hashes, sampling by entity rather than row, preserving rare classes, and documenting sampling assumptions. I would avoid blindly taking the first million rows because that can create time or ordering bias. For a reproducible random sample, I might use a stable hash of user ID. If the outcome is rare, I would use stratified sampling so positive and negative classes are represented. I also sample at the entity level when user behavior spans many rows. After sampling, I compare key distributions against the full population to check representativeness. Question 24. How would you compare two versions of a feature table to ensure a pipeline change did not break anything? This question evaluates your data validation approach, including reconciliation, row-level comparison, aggregate checks, null analysis, and confidence building before deploying AI pipeline changes. Be sure to mention row counts, key coverage, checksums or joins, distribution comparisons, tolerance thresholds, changed columns, and investigating differences before release. I would compare row counts, distinct keys, null rates, and summary statistics for each feature between the old and new tables. Then I would perform a full outer join on primary keys to find missing or added records. For numeric features, I would calculate differences and apply tolerances where rounding changed. For categorical features, I would compare frequency distributions. The goal is not zero difference every time, but explainable differences aligned with the intended change. Question 25. Describe how you would design a SQL feature table for a churn prediction model. The interviewer wants to assess your end-to-end thinking across schema design, feature windows, labels, entity grain, leakage prevention, and practical model-ready dataset construction. While answering, focus on one row per prediction entity and date, historical feature windows, label horizon, primary keys, null handling, and reproducible feature generation logic. I would design the table at one row per user per prediction date. Features would summarize only prior behavior, such as logins in the last 7, 30, and 90 days, support tickets, spend, and engagement trends. The label might indicate whether the user churns in the next 30 days. I would include prediction date as part of the key to enforce time awareness. This structure supports training, backtesting, and production scoring consistently. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.